Hey guys, so I've been studying a lot for my pathology board exams, and I absolutely hate remembering translocations and just random numbers and letters and all the combinations of everything when you're trying to study for board exams. This lecture is going to be looking at how to remember translocations for benign tumors of fat or your adipocytic tumors. They're very silly, and I know it kind of takes a little bit of stretch of the imagination, but I thought maybe it might be helpful for everybody. So what we're going to look at, we have lipoma. Going to be looking specifically at the spindle cell and pleomorphic, or spindle cell slash pleomorphic, angiolipoma, chondroid lipoma, and an intramuscular lipoma. Not all of these have the translocations, but these are just the high yield ones to know. Then we have a hybrinoma and lipoblastoma. Now in general, just to kind of frame your mind, lipomas are in adults, hybrinoma is kind of a younger adult, and then lipoblastoma is very young. So it's starting from older going to the youngest. And lipoma is by far the most common, so I figured I'd start there. So what do you need to know for pathology boards? Lipoma, that we have to do 12Q, which is HMGA 1 or 2, and 6P. So the big thing is this 12Q. Oops, messed that up. Okay, so 6P. The big one is the 12Q here. And the way that I like to do this, like I said, it's going to be weird, so bear with me. But kind of 12 over here, so that's how I get the 12. And then you can kind of make it also a Q with that. So that's my Q. And then for the 6, I go over here. And we can remember it's 6P because here's the P. So 6P translocation. And then 13Q is 13. So that's a 3 and a 1 right there. So that's 13. And again, we get kind of into your Q over there. And that's a deletion. Okay, so that was lipoma. This is the most common tumor, or most common fatty tumor. Overall, it's the most common soft tissue benign tumor. So that's just some high yield stuff to know. There's a couple variants. You have your conventional lipoma, intramuscular, myolipoma, fibrolipoma, myxoid lipoma, and chondroid lipoma. We're going to go over a couple a little bit later. To look at the spindle cell or pleomorphic lipoma, this is one that can kind of be mistaken for a well-differentiated liposarcoma or an atypical lipoma. They kind of go by the same name. It's all on a spectrum. But there are quite a few things that you need to know for this. So one thing is that there is a variant called mammary type myofibroblastoma, which is associated with a retinoblastoma gene loss. So here I have retinoblastoma. And if you count the letters of this, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 letters overall. But what it's associated with is a 13 Q deletion. So it's retinoblastome. And then you remember that there's one letter is being left off. So here's 13 letters, and that's 13Q. And kind of the A over here, it kind of turned into the Q. As you can see, I do not check Facebook. Here is the deletion aspect of that. And just like we saw in the previous thing with lipoma, I like to kind of make it a weird 3, 13. So that's 13 there. And 16 I have up here. 16. And again, I'd like to remember that it's a deletion by saying spindle, so D-E-L instead, deletion, spindle. Okay, so that's how I remember the 16q deletion. And then, like I had mentioned, is that it can sometimes be confused with atypical lipoma or well-differentiated liposarc, which those are known to have MDM2 positivity, or meaning that they're amplified or overexpressed, whereas this is a negative, so it's not amplified. Oh, and then to remember retinoblastoma, that's the other thing. Here is R, and then I do B, so retinoblastoma. So spindle cell pleomorphic lipoma, 16 deletion, retinoblastoma gene, which has 14 letters really, but since we're chopping off that A, you end up with 13. So 13q deletion. Another thing about this is that they, as the name implies, pleomorphic means that it's variation and looks very ugly. You can have a small cell next to a ginormous cell. And one thing that kind of helps point to a pleomorphic lipoma are these floret cells that are CD34 positive. And all that it is that, here's a kind of a adipocyte, and then the nuclei are just really ugly, and it kind of makes it arranged like a flower or floret, think of it that way. And these are very they can be hyperchromatic, but usually it's not as bad or not quite as severe as your atypical lipoma. And the big thing is that it's MDM2 negative here. Okay, so that's how I remember the spindle cell pleomorphic lipoma. Next, looking at hibernoma. So this kind of stretched your imagination here, but this is associated, it's a tumor of brown fat, first of all. So brown fat is what's normally seen in kids because you're growing and you need to have all this extra energy to kind of keep going on. So in the name, there's hibernoma, and I like to say hibernate, or think of a bear that's hibernating. So I think of a brown bear. He's hibernating. So here is the bear. So cute. And one thing, brown fat is different from our normal fat. Normally, fat would be, here's kind of the fat cell, and then you have your nucleus kind of pushed off to the side. It's not really indented. And then you have this big cytoplasmic vacuole, which is the fat that during processing is removed, and that's why we're left with this empty space. So hibernomas are different, or the brown fat is different in that it kind of, so here's the big eyes, it has a centrally located nucleus. Oftentimes you can see this big prominent nucleolus, which is, this area here. And then there's kind of these little fibrous septate. It's a little bit more pink whenever you're looking at the actual histology picture. So that's kind of how I like to visualize it here. This is a bear, and bears hibernate and they sleep. So this is a bear that is not sleeping. So here's his nose, and there. Now, the story I make up in my head for this, as you can see down here, this is an 11q rearrangement. Most common, it can be 10q as well, but here I just put 11, and then this kind of looks like a Q, so whatever way to remember that. And then these are the brown fat, so that's the way I like to remember that. And this is a brown bear, B-E-A-R, and he is wanting to hibernate during the winter. And one thing to note about this brown fat is that it's full, like the cytoplasmic vacuoles are full of mitochondria, which are your powerhouse to make ATP. So you have mitochondria, and they're full of ATP. And as you can imagine, whenever you're sleeping all winter and not really eating a whole lot, you need to have some source of energy. So that's kind of how I'd like to think of it that way. And one thing to mention is that this is neutral fat because of this rich mitochondria. Now, hibernomas can make steroid hormones, which, again, thinking back to a hibernating bear, you're not really doing a whole lot besides sleeping. There needs to be some sort of anabolic process going on, so it's a way that I like to think of it that way. And let's see if there's anything else to mention here. Nope, I think that that's it for brown hibernoma. This is usually in a kind of younger adult, like maybe old kid. They should not have a whole bunch of brown fat, but they still do. So, and it's a collection. It's very well circumscribed, and that's the way to remember hibernoma. So some things to mention here. Angiolipoma doesn't really have a specific translocation to remember, but the clinical that you need to know is that it's a young adult, oftentimes it's like a male, teens or something. They come in that have a forearm mass or maybe even masses, multiple masses, and it's very painful. And what it is, when we look at it histology, is that there's a bunch of capillaries, and the big thing to note is that there are fibrin thrombi within all of these capillaries. That's a big clue there. There is somewhat of a familial inheritance here with autosomal dominant. It kind of runs in families. It's thought to possibly be a hamartoma, but there's no real evidence of that yet. Okay, and then chondroid lipoma, the clinical that you need to know for this, it's usually an adult female that comes. They have a mass either in their thigh, arm, shoulder area, kind of deeper, or not too deep, superficial. It can be subcutaneous or intramuscular. Most of the time it's a little bit on the subcutaneous aspect instead of intramuscular. And this does have the same translocation associated with hibernoma with your 11-16 translocation. Okay, and then lipoblastoma, as I mentioned, this is the smallest, or the one that presents in the youngest, so we have a neonate population. And as you can see here in the name, it's lipoblast. One thing to note about the lipoblasts, I've drawn one here, is that the blast is the one that's always proliferating. And so here are, if it's a fat cell, it's trying to make a whole bunch of fat. So as it tries to make all this fat, it ends up making the cell kind of swell up. And as it grows, the nucleus that was in the center and being nice, wasn't compressed or anything, now it's starting to be compressed by all of these fat globules. So this in the center is your nucleus, and it is indented by these cytoplasmic droplets. So that's how you can tell this is a lipoblast compared to your hibernoma or just a normal fat cell. So lipoblastoma present often in the extremities or in the trunk area of the neonate. And the translocation to be aware of is this PLAG gene, which is the same one that's also seen in a pleomorphic adenoma, one of your salivary gland tumors. And it's an 8q chromosome for that. So to remember that the 8, you can see here, lipoblastoma. So I like to put the 8 there. And the Q can, be here, there. And then to remember that it's the PLAG gene, you can see there's P, L, A, and G. So PLAG gene. Yep, so those are some simple ways to remember. The benign fatty tumors. I'm also going to do one on the malignant liposarcomas and all the different variants coming up in a different lecture. Okay. If you like it, let me know. If you don't, let me know.